So hello everyone. So our today's lead code question is 2977, that is a minimum cost to convert string part 2. So yesterday also we have seen a same question, but there are slight differences in both these questions. So let's see what are the differences and how we will be tackling those differences. So here also we are given two strings, source and target, and we have to convert our source string to target string, and with that we are given so yesterday's question we are given character arrays, but in today's question we are given two strings arrays, original and changed, and an integer array cost. So cost of I represent the cost of converting the string in the original array at index I to the string in the changed array at index I. So what we can do is so next so we are so we have to start with the string source, and then we can pick a substring. In yesterday's question we are allowed to pick a character, but today we can pick a substring x from the string and change it to some substring y at some cost z. So what it is showing that it is saying that we can take a substring from the source string and change it to some other substring if it is present in the changed I and with the some cost that is given in the cost of I. So but there are some conditions that are mentioned here, that the substring picked in these operations are, suppose we pick a substring from index A to B and other substring with index C to D. So the condition of picking these substring is that the index B is less than index C, or index D is less than index A. So in simple terms, if we say that these two substrings should not be intersecting, like they should be separated, they are like disjoint, they can't be intersecting substrings. I'll show you ahead with an example. And the second condition is saying that uh, we pick a substring with index A to B and other substring with C to D, and in this one A is equal to C and B is equal to D, it is showing that we can perform the operations again and again on a substring, right? And at the end we have to return the minimum cost or minimum cost to convert source to target, and if it is not possible to convert, then in that case we will be returning -1. So we will be looking these two conditions again with examples. So condition 1, what condition 1 is doing is it prevents the partial transformation. Means if two substrings are what we called overlapping, then those can't be considered. So I have given you an example. So here source string is abcd and target string is acaa, and the original string is bc can be converted to cd with the cost of 2, right? And dd can be converted to aa with the cost of 5. So if you'll see, can we convert our source string to target string or not? So let's see. So if you'll see, maybe you are thinking that first you will convert BC to CA, then our source string will be AC, or sorry, CD, right? Then our source string will be ACDD, right? And after this you will convert DD to AA, then our source string will be ACAA. But what is our first condition saying? So here in operation 1, what we have done is we have taken from string from 1 to 2, and in operation 2 we have taken string from index 2 to 3. So if you'll see these two ranges, they are intersecting with each other, like 2 is common in both these two. So our condition 1 was saying that the substrings that we pick should not be intersecting, they should be disjoint. So in this string, although it appears that we can convert source to target, but our condition 1 is failing. Here 2 is common, 2 is common between these two, so condition 1 is failing, so we can't change from source to target, so our answer is -1 in this case. I hope you get it. Next, let's move to condition 2. Our condition 2 is saying that we can do any operation and any number of times on a particular substring. So what this is saying, that suppose a string is there ABC. Let me show you by writing here. Suppose a string is ABC, that we have, that can be converted to DEF, and another string is DAF, that can be converted to GHA, and we have to convert ABC to GHA. But directly, if we'll see directly, there is no, what we called, no rule to convert ABC to DHA. But our second condition is telling us that we can do any number of conversion any number of times on a particular substring. So what we can do is we can first convert ABC to DEF and then DEF to GHA. So we are getting ABC to DHA via some other intermediate step. So I hope you get the two conditions right. So if you'll see the summary of both conditions, the what it is saying, that the string is divided into independent blocks. That is, suppose our string is this is our string. So if we are converting this via one operation, then this rest of the string we can convert with other operation, but there should not be overlapping of the string in conversions, right? And each block can be transformed multiple times. The our second condition is saying that each block can be transformed multiple times, but blocks should never mix. So you should keep these two conditions in your mind, and then we will be solving this question. So let's see an example. So here source is given ABCD and target is ACB, and we are given some original and change array and some cost. So see, how can we change? A and A same. Now we have to convert B to C. So we will check any rule is there or not. So B to C rule is there with cost 5. Then C to B. Is there any rule from C to B? Yes, C to B a rule is there with cost 5. But there is one more rule also. If we convert from C to E and then E to B, then our cost will be 3. So our cost to convert B C to B directly is 5, but via E we can convert it using cost 3. So we'll be taking this, and then D to E cost is 20, right? So overall cost is 20 plus 5 and plus 3, so 28. So this way we'll be solving this question. Next we'll see another example. Here we are given A, B, C, D, E, F, G, H and target this and the original arrays, and we can convert to these arrays with cost 135. So A is A, already same. B, C, D. B, C, D we have to convert to C, D. Is there any rule? Yes, a rule is there with cost 1. So B, C, D is converted to C, D using this rule. Then E is same with E. F, G, H. F, G, H we have to convert FGH, we have to convert GHH, but there is no direct rule. So what we can do? Convert FGH to THH and then THH to GHH, right? GHH. So total cost will be 5 plus 3 8 and 1 9. So our output is 9. Then let's look to the constraints. So our source array can and target array's length can be up to 1000, and the cost length, original length and the changed length, those arrays length can be up to 100. So if you'll see, our constraints are smaller, not like too big, and even the original I of length and change I of length means the strings length of the strings in the original array and the change array can be up to the length of the source length, like can be up to 1000, right? And the cost of I can be up to 10 ki power 6. And now let's see. I hope you have solved the yesterday's lead code daily question, which is 2976. So it is, or both these questions are almost similar, but there is a slight difference. So in yesterday's question, what we are given is the length of the strings is original and changed is only one. So today the length can be 2, 3, and so, but yesterday it was only one. So that means we can change one character to other. So what we have done yesterday was that we have made a graph. We have made a graph of all the characters that we can change. So A to B cost is 2, B to C cost is 5, C to E cost is 1. So suppose I have to change A to E. So what I'll do is I'll find the shortest distance between A to E, and then the shortest distance will tell us the minimum cost that I take to convert to A to E. So, and using Flyod Warshall algorithm, we can find all the shortest path or shortest minimum cost between all the characters pair, right? So this thing we have done yesterday, but in today's problem, if you'll see our today's problem, the first thing is that length of the strings is not fixed, like it is not fixed to 1. It can be vary from 1 to the length of the source dot length. So what we can do, like, and but one more thing is that one more thing which makes our what we call solution easier is that we can convert a length string to a length string only. Suppose there is a string abc ABC. So if we can want to convert ABC, then we have to take a string of length 3 only, it's like DEF. We can't do this conversion ABC to DEF. That is not allowed. We have to convert L length string to some other L length string only, right? So if you'll see the yesterday's question, what we have done yesterday was we make graph graph for all the characters, and then find the relation between those characters, and then find the minimum cost. So using the same thing, can we do something here also? So if we'll make different graphs for strings of different length. So suppose I make for length 1, I make one individual graph. For strings of length 2, I make other graph, right? And then what we can do is we can use the find the minimum cost using Flyod Warshall algorithm, which we have done yesterday. And then in each graph of length L, to convert a string of length L to another string L using graph of string L, we can find the minimum cost. Suppose I have made a graph of all the strings whose length are 3, and then using Flyod Warshall I have find the shortest path among all those strings. So I got the minimum cost to convert string this one to string 3, right? So we'll be following this lead, but once we get the shortest path, suppose we have made all the graphs of different lengths, find the minimum distances between all the strings, and then how, but suppose we are at some index, then how we should know how much length substring we have to replace, how we will be solving this. So for this what we will do is, what, suppose we are at some index I. So what I can do is I can try all possible length strings from that index to the last of the array. Suppose I'll let me explain this with you an example. So our source is abcda and our target is bdcxa, right? And these are our rules, that is 8. If we convert a to b, cost is 5, ab to bd, cost is 1, cd to cx, cost is 2. And suppose right now I am at index 0. So what I do is, for length 1 I have to convert a to b. So I'll be checking, is there any valid rule? Yes, a valid rule. What is the cost? Cost is 5. right? Then at index 0 I'll be checking length is equal to 2, so means AB to BD. So I have to convert AB to BD. Is there any rule present? Yes, present. So what, and the cost is 1. Then length 2 is also there, so let's check length 3 ABC to BDC. So no rule exists, so we can't be proceeding with this one, right? This way we'll be checking all the possible lengths. L is equal to 4, L is equal to 5, and so on, right? And suppose somehow we know the cost of, for length is equal to 1, A to B, and suppose we also know the cost to convert BCDA to CDXA. Somehow we know this cost, then our total cost will be this cost 5 plus this cost of BCDA to DCXA. In the case 2, when length is equal to 2, if we know the cost of CDA to CXA, CDA to CXA, if we know this cost, then our total cost will be 1 plus this cost, right? So if we'll see our final answer, what will be our final answer? The minimum cost that we get from these operation, like cost 1, cost 2, and if suppose further costs are there, so the overall minimum that we get, that will be our final answer for index I, right? And at the end what we have to return, we have to return for 0, right? So if you have noticed, we need future computed cost here. In the above I have shown you like future computed cost. If we need those future computed costs, so we can start from and start the store the cost. So what is this problem heading towards? So this problem is, if you'll see, we are moving towards DP, like store the pre-computed things and then use those pre-computed costs. So what DP of I will denote? So DP of I will denote the minimum cost to convert source source substring from index I to last to target string from index I to last. I hope you get it. So DP of I, like the value at index I in the DP array, will tell us the minimum cost to convert source array from index I to n to target array from index to I to n. Minimum cost, right? So suppose here DP of BCDA to DCXA, if that is present, then our answer will be DP of 0 is equal to 5 plus DP of this index, right? Now the next question is how we will be calculating DP of I, right? So let's suppose at index I we have taken a substring of length L. At index I we have taken a substring of length L. So what will be our cost? Cost is the rule to convert this, like the minimum distance to convert source of I to I plus L minus, the like substring I to I plus L minus 1 to the substring present in target, like the minimum cost. So this minimum cost we will be getting from the graph that we have pre-computed and stored using Flyod Warshall, and then we'll be adding DP of I plus L. So DP of I plus L will tell us the minimum distance from I plus L to end. So this is minimum, and if this is minimum, so this will be taking a, this will be storing in a variable, and this will be computing for all the possible lengths L, and at the end what we will do is DP of I is equal to minimum of DP of I comma the overall minimum, yeah, the cost that we get by here, right? So if we'll see the whole approach in one go, what we have to do is, first of all we have to find all the strings of different lengths in the original and changed array. So we'll be finding all the different lengths. Then what we'll do is we'll make graphs for different lengths of strings separately. For length 1 we'll make one graph, for length for strings of length 2 we'll make separate graph, and this way we'll be making different graphs. And then in each graph we'll be finding minimum cost to convert one string to another string using Flyod Warshall algorithm, which is the minimum distances between those two strings, right? Once we get the minimum cost to convert one string to another string, then what we'll do is we'll start from the end of the source string and then apply dp at every index. And I have already mentioned how we'll be updating the dp, and at every index we'll be trying all possible length substrings that we can change, and at the end we will be taking overall minimum cost and store in dp, and our answer will be dp of 0. That is the minimum cost to change string from 0 to last to target string from 0 to last, which is our uh, goal, right? So if you'll see the code, in the code we have simulated infinite. Infinite is simulate we use infinite to show that there is no connection, and then source size and original size we have stored those. Then in the first loop here what we are doing is we are using a unordered map in which we are storing this int like different lengths. So suppose there is an string whose length is 1, so original of height dot size, it will give us the length of the string, and we are pushing the index here. So suppose at index 0 the string is of length 3, so by len of 3 is equal to 0, we are pushing that index. So at the end we will get a map of int comma vector which have different lengths as 0 1, length as 2, and so on. And here the indexes of the string, suppose uh, index 5, index 4, index 3, so index 2. So if you'll see, uh, the string of length 1 are present at index 3 at index 2. So this way we have stored all the strings of different lengths in a map. Then after this what we have to do is we'll be using two unordered map of int comma unordered map of string comma int. So we can't simulate strings in a graph. So what we have to do is we have to give unique IDs to each string. So here this unordered map, what it will do is it will give a unique ID to each string. Suppose first string is abc, so abc have id 1, so means node 1 denotes abc in graph of length 3. This int denotes the length, this string denotes the string, and this int denotes the id, right? And this second unordered vector, what this int again denotes the length, and this is vector of vector. So that's the original graph where we are storing the distances that we compute by using Flyod Warshall. And then once, okay, so after this what we'll do is uh, we'll be taking the length of the string and the indexes that we have stored in the map. So suppose we get length as 1 and the indexes as 0 3 5. So this way we get the indexes. So what we do is this is a function, this is a helper function. What it does is it will give us the id and then push the strings in the this nodes vector, right? So if you'll see, we'll taking all the we'll be iterating over all those indexes, and then taking the original array sorry string from the original array at that index and string from the changed array at that index, and then adding and then calling the add node function, which is this function. So this function will be giving a unique id to the string and then store those strings, and these unique IDs are further used to make the graphs. So once we get the strings and their unique IDs, what we do is we what we do is we will be using a vector of vector, like we will be using this to make the graph, and then distance of each node to itself is 0, and then what we do is we'll be adding the edges in the. So original of index is directly uh, connected to changed of index, right? So we will be adding an edge between these two, and the adding the cost of the index, and then after once we made our graph, we'll be using this Flyod Warshall algorithm to find the minimum distances, between the graphs of between the different graphs of different lengths, right? So once we get the minimum distances, then what we will do is we'll be using our dp and then we will be iterating from last on the source string. So if we'll be checking for if source of I is equal to target of I, then dp of I is equal to dp of I plus 1, because there is no conversion, so it is 0 plus next the dp of I plus 1 tells the minimum cost to convert source string from the index I plus 1 to target string from index I plus 1 to last. So we'll be adding that cost, and we'll be storing uh, in that dp of I, and then in option 2 what we'll do is we'll check for each length l is equal to 1 to like all the feasible lengths, and suppose if I plus l index plus length is greater than the size of this array, then we won't be taking that length, else we will be taking the substring from index I to l in source and index I to l in target, and then if these two strings are not present in the graph, means there is no rule, so we can't convert those two. We'll be checking whether these are present in the graph or not. If they are not present, means they can't be converted, means there is no rule, so we'll be skipping this. And suppose if they are present but there is no edge between these two, if there is no edge between these two, then also we'll be skipping, else we'll be updating our dp of I by this distance that we get between these two strings plus the future cost that we have already calculated for dp of I plus l, and at the end what will be our answer? Our answer will be dp of 0. So if dp of 0 is greater than or equal to infinite, means there is no solution that can convert source to target. In that case we will be returning -1, else we will be returning the answer at dp of 0. So this is like ternary if. So if the condition satisfies, then this will execute, else this will execute. I hope I am able to explain you this question properly. So if you'll get it, please make sure to like, share and subscribe the channel. Thank you. That's it.